All right. Welcome. Welcome to my, I guess this is the second stream I've done on this, but the very first where we're actually going through the book's contents. So in case you missed my last video, I will quickly, I'm still playing around with the idea of stream music. I'm not sure if I even want to do that. So I'll turn it off for now so I can at least think. The idea for these streams is a semi-regular, or at least as regular as possible, live stream where I go through some sort of a technical book. My background is in systems programming, and so it'll be something related to that. My hope is that you participate with me. So again, you could kind of treat it sort of just like any other book club, right? Where you instead of going to a book club to read the book, you've presumably already read the book. I know that's kind of a meme, right? Like, not all book clubs actually do that, but in this case, I'd like to. The point of these streams is effectively to sort of like come together about the topic in question. So I might give my perspective and sort of like give some prepared structure just to keep it interesting. But I'd like to also ensure that anything that you find interesting is captured as well. So I would really love it if you're watching this recording, I'd love it for you to join live, and that way you can sort of tell me what you thought was interesting. I'm learning alongside you all. So without further ado, again, in case you missed that first video, not this one, although that's a really good one that I might do later. The book in question is Systems Performance by Brendan Gregg. And so we will be going through that. And if you'll allow me to quickly pull up my notes and also actually open the book so that we can sort of go through that. This is I think I'll mention this here probably a few times. This will be a shorter stream today just because I wanted to keep it limited to chapter 1. I don't generally like to... I was trying to map out sort of what each stream would involve, and at times there will definitely be times where we need to split a single chapter up into multiple streams. That's just unavoidable. Some of these chapters are fairly dense, and my target is sort of like 1 to 2 hours per stream, so that's unavoidable. But what I didn't want to do also is sort of like split like a single stream across chapters. Like that didn't really make a lot of sense to me. So we'll have to play it by ear. But yeah, today we're starting with chapter 1, and chapter 1's pretty light, so we'll sort of keep it at that. Just checking on things. So yeah, so some housekeeping up front, especially considering this is the first stream. The first thing I'd like to call out is I'm learning a lot of these topics along with all of you. My goal here is not, again, to sort of like this is going to be pretty informal. Obviously, I'm going to try to keep it interesting. I'm definitely going to prepare some stuff up front. But my thinking going into this is not that I'm creating sort of like a tutorial or a prepared lecture or anything like that. I have some experience in the areas where, where, especially for this book, I have some experience, but I'm learning along with all of you for the vast majority of at least certainly the depth of what this kind of book goes into. And so I will just be learning alongside the rest of you. And so for that reason, I'll intentionally leave a lot of space for interactivity. So that means engage in chat, like get into one of these live streams. I have chat right here on the screen. If you pop in and say, hey, like this is what I thought was interesting, or maybe you think I glossed over something, say so. I would love the opportunity to sort of divert into something that I know is useful to somebody. That's kind of the vibe that I'm going for here. So any sort of like rabbit holes, redirections, tangents, like all that's encouraged. As I mentioned, I do have some experience in this area, not as a sort of explicit focus, of course. I'm talking specifically about like systems performance. But I have, so I have some experience in sort of running, building and running production systems. So I'll be sharing some anecdotes in that regard. But like I said, this is, for me personally, one of the reasons I selected this book was to sort of fill in, like focus on systems performance as a discipline, not just as a something that you are forced to do every once in a while. When you are running some production system or product or something like that. So That is sort of the overall goal of what I'm trying to do here. Now, let's talk about expected pacing. I mentioned this in the previous video. Again, the previous video is sort of just like talking about the concept, and I've thought a lot more about the specifics of how I want this to go. And so that's sort of what I want to get into now in terms of pacing. I mentioned a little bit ago that generally, and certainly today, I'm going to try to do a chapter every stream. That may or may not always happen. My goal isn't to sort of stick to a certain like boundary within the book, like a chapter per stream. Like that's just not going to work because some chapters are just very dense. So instead, what I want to do is I just want to make sure that the stream is anywhere between 1 to 2 hours. Now, again, how that translates to the books, like the page count that we get through in the book, obviously that depends entirely on the density of the subject matter that's sort of next up. Again, today's probably going to be a little bit shorter than usual, maybe even under an hour. It just kind of depends on how this goes. Of course, I'm talking a lot at the very top of this, so who knows? Maybe it will go over an hour. And then again, I expect that in some of the denser chapters, we will have to do partial chapters, like per stream. Like some of the chapters we will have to do over multiple streams. In other words, so that's pacing. The other side of that is frequency. So again, what I want to do is be predictable in these streams. I don't want I don't want to sort of just like stream in a haphazard way and make that harder for you all to join. So I want to make that as predictable as possible. That said, I can't commit to every week. I have on-call duties at work, and then a bunch of other life things that will require that every once in a while I skip a week. However, I also don't want to go longer than 2. So I'll say let's do every 1 to 2 weeks. I will try to update my Twitch schedule accordingly. My understanding is that I can't set up a bi-weekly schedule, which is fine because I think that's probably too rigid anyway. Like there are probably going to be some weeks where I actually want to stream like 1 week after the other because maybe the subject matter is like really interesting and I get into it, and maybe the rest of my life gives me the cycles to get through that. So I don't want to commit to bi-weekly either. So we'll say 1 to 2 weeks. The advice that I'll give is stay tuned to the Twitch schedule. I think I can set up like a weekly schedule and then just like delete the weeks that I don't want to do. So I haven't confirmed that, but I think I can do that. All things being failing that, if you follow me on any of my socials, and if you go to oswalt.dev, let me just share my screen, and that way I can at least show you what I'm talking about. oswalt.dev/links. Nope, if I can spell it right. This is where I'm putting all my socials. It's sort of my own like personal link tree. So follow me on any of these that you think is relevant. Maybe not GitHub or RSS, but Blue Sky, Facebook, LinkedIn, and Twitter, and then of course Twitch and YouTube. Twitch is what you're watching this on now if you're live, and if you're not live, you're probably watching this on YouTube. So either of those are sort of for consuming the stream and the video, but then all the other socials I'll try to post when I make a change. So if I unexpectedly need to cancel the next week's stream, I'll do my best to say so there. Obviously, also I'll try to predict that a little bit at the end of each video. So at the end of like today, for instance, I'm planning on giving an estimate for like when the next stream is, how much content that should cover, and so on and so forth. So also staying tuned in the actual live stream helps give some estimates there. Okay, great. Let's see what's next. Now, in each stream, let's talk a little bit about the expected format. Again, I want this to be fairly informal. I want it to be interesting, so I want a little structure, but I don't want to put too much structure on it for a couple of reasons. One of which is that it won't be sustainable if I try to be rigid about this. And the other thing is I can be a perfectionist, so if I sort of try to put too much structure over the top, I'll latch onto that, and it'll sort of slow me down effectively. It'll burn me out effectively. I know myself well enough to know that that's going to happen. That's something I'll mention. And you know what? Actually, I'm going to use my scratch pad. I was thinking that I didn't want to do that just yet, but I am going to do that. So let's see, pacing. What did I say about pacing? So pacing somewhere between 1 to 2 hour streams. So whatever portions of the book fits into that. Frequency. Oh, may need to split chapters across multiple streams. Frequency, every 1 to 2 weeks. Follow socials at Great. Okay. So yeah, as I mentioned, this is going to be kind of informal. Oops. Oops. Oh, I see. I forgot to do a new line there. All right. Informal, not too much structure. So the structure that does exist, I'm thinking, will be generally a little bit of housekeeping up front, similar to what we're doing now, although I won't have nearly as much housekeeping in the subsequent streams because this is the first one. So housekeeping and just sort of open discussion. So if you want to sort of kick things off and give me some like ideas up front for things that you'd like to explore, that'd be great. The earlier the better, actually. So yeah, that works for me. So we'll just sort of just kind of have like a small amount of time up front where we kind of just all, get kind of like in that first 10 minutes of like a conference call where everybody kind of filters in slowly. So the meeting doesn't actually start until 10 minutes in. Although in this case, I don't mind it. So yeah. And then let's see. I'm going to actually move this over back over where I had it more readable. Okay, great. So that's the first section, and then the second section is the sort of most important one. So talking through chapter. So I have notes, and you'll see me looking off to the side, reading through them, just to make sure that I remember like what I noticed. But my methodology, and this may or may not be useful to you, is as I read the book, I look and learn and consume, and then anything that stands out to me, either hey, I learned something, or maybe there's a topic that I already knew, but also I realized like, wow, that actually is really important to call out. And maybe I'll have an anecdote in mind where the author will say like, hey, like this is how you would use this methodology, and here's where it can be useful. I might have an anecdote to sort of reinforce that. So I'll take notes that like are on a per page basis. So in my notes, I say like, okay, page 1, here are my thoughts on that. And I'll just go linearly through that. So I'll be referring to those notes sort of off to the side here. That's just, again, what I prepared. It's sort of the things that I thought were useful that might be worth calling out. Again, the goal of this is not to sort of regurgitate the book as a whole. Like, you should have the book. That's kind of like the idea of the book club. But I also want to like sort of provide some interesting call-outs on my part. However, again, that is not meant to supersede yours. Like, the whole point of doing this live is so that you can join in chat and provide the thoughts of your own. And I will actually deviate from my notes to go into whatever you call out. Like, if you say something that is interesting, I will make sure that it's given sort of preferential treatment, unless there's a real reason to save it for later. Like maybe it's like further on in the chapter and we haven't covered it yet. But generally speaking, I will definitely prefer to talk about what you might call out in chat, because that's half of the value that I get out of this is hearing somebody other than myself talk. I like hearing those other perspectives. Okay, so yeah, that's the biggest section, and then I'll just say like throughout and perhaps at the end, live demo. And I'm going to just be really hand-wavy about this because, again, it just totally depends on the subject matter. I actually had a live demo prepared-ish for today, without realizing that it's like mostly for chapter 2. So I actually trimmed that for today, and that's one of the reasons why today is going to be a little bit shorter. But there's some tools that are very briefly mentioned in this chapter, but then they're explored much more deeply in the next chapter. So it'll be good to cover them there. So when I say live demo, it could be at the end. Like maybe I'll go through all my notes and I'll say like, okay, now let's actually go back to some of those concepts, and I'll show you like a demo of like how this can actually work. Or I might do that in the middle of the notes. Kind of just depends. But just at some point, some live interactivity will be part of this. And I have a quick note on that before I go to the last section, and that is actually, if you go to my GitHub, and here I'll post the link here shortly. And any links will be in this scratch pad, which which I'll actually put in the GitHub, but I'll try to put the link to the GitHub somewhere else too. So this Git repo I just threw up today. It's pretty simple right now. It contains really only a few things. First of all, this is the first book club stream, so the content is really focused on this particular book. Obviously, as I get to more books, and provided this is still a format that people are finding useful, I'll add more to this. But for now, it's going to be systems performance, probably for the next few months. It's a big book, so that's not too terribly shocking. But there's a few things in here, one of which is just, again, a high-level overview of like what the book club streams are. But if you get into each directory, so let's go into the systems performance directory, you'll notice that inside of here, there's actually some Terraform files. And the reason for that is because I wanted to provide, first of all, it's a little bit of laziness on my part. I don't like poking through web GUIs. And actually, it's been a long time since I used Terraform, or really any cloud provider. It's not strictly true, but just like regular, I used to do it a lot more, and just like for the past couple years, I have not done a ton with it. So I had to relearn Terraform a little bit. But it's pretty simple. It's basically just spinning up a Linux VM. And again, the reason for that is because I'm going to do some live demo stuff, and I want to A, not do it on my system. B, I want a reliable way of showing that. In a predictable way. And then C, of course, it's sort of like great for you to follow along. If you have a GCP, a Google Cloud account of your own, you can just use this exact same thing and bootstrap it. Obviously, you don't have to. If you want to spin up a Linux VM in your own cloud, you're more than welcome to do that. This is just a convenience thing. And so that's why the Terraform files are there. It's just what I'm currently using for this book to do a live VM. Now, I'm going to use the one VM across all the streams, or at least I'm going to try to. If I have to deviate from that, I'll try to let you know. But I can't imagine why I would need to. So I'll add to it, but the single Terraform infrastructure for the whole chapter, and if I need to add to it, I'll add to it. Now, within each of the subdirectories, so there's one for stream 1, right? So you have stream 1, and that's today. It's empty because, again, I don't have any live demos that I'm going to do today. But in stream 2, which I'll be posting sometime before stream 2, I actually have a Rust project that demonstrates high CPU utilization. I'm really excited about that, actually. So the TLDR is anything to do with anything to do with the stream, like materials that are sort of meant to augment the video, the recording, or the live stream, I'm going to be putting in here. So definitely follow along in that, clone it, and fetch regularly. And then finally, just the last section. Again, this is even more formal than I was really hoping to get into, but it's good to just keep things on track. And that is just discussing sort of like what the next stream is going to look like. So wrapping up, covering anything that maybe are lingering. So again, if you pop up in chat and say like, I would love for you to explore this. If I haven't explored it yet, we'll do it then. I don't want to end any stream without at least mentioning something about what's interesting to you. So there's that. And then next stream, we'll be talking about content and pacing. Now, again, this is an estimate. So the guidance I'll give here is follow along on my socials for updates, because again, I might get it wrong, and probably will. Almost certainly will, actually. I'm just gonna put my money on I'm gonna get it wrong, because what I will try to do, like today is a good example. I've looked at chapter 2, but I haven't read it. Like I haven't actually gone through it yet. And so my high level estimate of how long it might take just might be totally wrong. And frankly, I expect that sort of the wrongness likelihood to increase over time. So yeah, I'll do my best to estimate that on each stream. But again, the best thing to do is to continue to follow on socials, so that you can be informed of, again, when the next stream actually will be, as well as what that stream will aim to cover. Okay. I am tired of this prelude. Thank you for bearing with me through that. Again, I intend on sort of the initial housekeeping section of every stream to be far more lightweight than that. Because again, the whole point is sort of like, housekeeping in the sense of like, hey, here's what we covered last stream. And here's how it leads into this one. It should really be as simple as that, and maybe just again listing the ways in which you can follow along if you haven't done that yet. But yeah, future streams I'm sure do better at getting into the meat of the topic. Okay, as I mentioned, I am going to go through my notes. I am keeping an eye on chat, and if anybody wants to chime in at any time, it's right here in front of me. I may not be looking directly at it, but I will look up at it occasionally. Otherwise, I'll be just going through my notes. Okay. Systems performance. This is the introduction chapter, chapter 1. So the first thing that I noticed is on page 1 and 2, and I really like how they organize that in the book. A lot of books don't have the page, and I don't know if that's the publisher. It might just be the publisher, but I don't know if the publisher does this. But the fact that chapter 1 begins on page 1, it's great. Really, really good stuff there. It's just like a quality of life thing that I appreciate. So if you're listening from Addison Wesley, kudos. Apologies, 1 second. I accidentally opened this dialog box that I don't want at the moment. Sure. Yeah, I think I want to put my notes actually right here. I think it'll be easier to keep track. Apologies, bear with me 1 second. That should be a little bit better. Okay. All right. Okay, so starting with page 1. The first thing that stuck out to me was, and again, just as sort of like a little bit of background on me and like my current skill set. I have elements of what's discussed in the book, but my background is very eclectic. In fact, most of my sort of, I would consider like real production, like systems programming experiences from the last couple years. Now I've been programming in various ways my whole career, but as part of that, I've also done like literally product management, product marketing. I did network engineering. I was a consultant for like years. So my background is extremely eclectic. So again, one of the reasons I'm going through this book is to sort of fill in the gaps that exist. Even though I have spent the last at least, I think, 4 or 5 years doing that, doing sort of more, again, like at scale production kind of stuff. And I know that's a hand wavy term, but there's definitely gaps, and I certainly haven't focused on systems performance as a discipline. So that's one of the reasons I'm going through this. But one of the things that I really appreciated early on is the call out that, and I don't know if he says this exactly in the book, but the note I wrote is that systems performance basically just has no boundaries, and that mirrors very much the perspective that I have gathered about the discipline of systems performance. And just for a note, my company actually has like a dedicated performance team, and they jump into anything. Like they literally jump into anything, which I think is awesome. I know a lot of companies have an SRE team, and sometimes SREs sort of take on a little bit of a performance, sort of performance management or systems performance task. But that's obviously every company is different. So it could fall to SRE, could be a dedicated team, could be just every team's responsible for their own performance. Nobody's responsible for performance as a whole. It kind of just depends on the organization. But yeah, in my experience, the discipline of systems performance, especially if it's given sort of like first class treatment, is it truly has no boundaries. And what I mean by that is, just about any software system worth its salt, especially if it's, like a hosted service of some kind where it has, it's somewhere, quote, in the cloud and users have to connect to it. Even the simplest of those can have very complex machinery behind the scenes. And so the idea that you could like think about systems performance only within the context of like one service, it just doesn't really bear weight. Like you can't really think of it that way. Even in a really simple service, there are usually a variety of other systems that your one service depends on, and so you still need to include them in the analysis. Anything along the life of I use the term, I don't know if this is unique to my company, but we could say life of a request. But effectively, anything along the chain of like user to your service to even your services like backend services and all of their dependencies, anything along the way can have bottlenecks. It can cause performance problems, and so the analogy that it's not even an analogy. The actual stack that Brendan draws now on page 2 is a really good, I think, demonstration of how this works within a single system. So, starting with the application, sort of the obvious thing, like maybe the application is doing something silly, but it has dependencies on other services, so like a database, but it also has dependencies on the local system, a lot of stuff in user space. I love to call out compilers because compilers do things that can impact performance, obviously. But I mean, I say obviously, but I think obviously only in retrospect. I think the point Brendan makes is that it's not always obvious that the compilers do play a role because they're not running all the time. Well, unless you're using an interpreted language, and then you can argue that that's kind of happening. But I understand that there's some nuance there that's way out of scope for this conversation. But regardless, like, yeah, that has a role. And then, of course, the operating system, like that's part of this. None of this runs without an operating system unless you're doing embedded stuff. So you have to consider it. And then, of course, if you're doing embedded, you kind of still have to consider it. It's just kind of all one and the same. So there's so much that I think is really easy to forget about, even on a single system, like a single server, like a single machine. And then that doesn't even get into anything to do with multi-machine implications. And so I'd argue, again, in a lot of situations, the software that you use day to day, it's not just one server, one physical server that sits there. I mean, it might be, but usually the dependencies that an application requires are across multiple machines, multiple organizations, multiple clouds. Like, it's so varied, and so you have to add into this diagram, like, so in addition to this, you have to like put that in the same context as also thinking about distributed systems patterns, network protocols, latency across the network, and things like that. And in my experience, it's really hard to find somebody that knows all of that fairly deeply. And one of the things that I've noticed about performance engineers is that they may not actually know the service. Like, say you have you're running a production service, and you probably know that service a lot better than a performance engineer that has never looked at it, right? They've never looked at it. So literally there's just inside knowledge that you have that they don't. But the sort of special sauce that I've seen about folks with this skill in this discipline is they have the ability to get into to become familiar with your service in a way that's almost embarrassing. Like they have these sort of like built-in instincts and shortcuts where they sort of treat any service as a black box, and they can just inspect it via these tools that are incredibly portable, and can translate the same sort of methodology, part of which we'll be discussing in the next chapter, to just about anything. And it's always so impressive to see that in action. So I wanted to call that out because despite all this complexity, performance engineers have a way to kind of apply the same methodology and the same patterns, kind of regardless of what part of that stack that they're looking at any given time, which I think is great. One second, I need to hydrate. Okay. And I could just tell my mouth is going to dry out if I don't do something about it. These little dry mouth lozenges are great. They're not medicated. I don't think it's like a active ingredient necessarily. It's just sort of like it's like a cough drop kind of thing. Anyway, it's very useful. I have a lot of days where sometimes like I have a lot of meetings. Not every day, but on days that I have a lot of meetings, they're a lifesaver. Okay, just checking in. I want to be mindful of the live stream. I'm not obviously this is the first stream, and so like I'm not going to be upset if not a lot of folks are watching, but I just don't want to ignore if anybody is. And so I'm just doing a quick check of that. Also, might as well check the stream health too, just to make sure that's going on. I used to have a few problems with that, but I think I've fixed them. So yeah, frames missed due to rendering lag versus encoding lag. There's just a very small percentage. I'm going to reset that counter just to make sure, because it could have been from a previous one. I haven't reset that in a while. Okay, great. So let's keep an eye on that. Back to my notes. Okay. Yeah, so I covered page 1 and I guess page 2. So let's go on to page 3. Page 3 is just the other side, and I just have a discussion topic that I wanted to kick off here. Obviously, if you have any thoughts in the moment, feel free to post in chat. Otherwise, feel free to post on YouTube. I will do my best to respond there. But there was a discussion. So activities is the the activities involved in system performance is covered on page 3. This is chapter 1, section 3, I suppose, and it talks about. There's a blurb at the end. Well, first off, there's a list of the different activities that performance engineering can involve. I thought that was cool because it's sort of like, again, like all in one place. You can kind of, if you're not familiar with this or you haven't focused on this as a discipline, it's good to sort of see the kinds of activities that a performance engineer might do. Great if you're considering like making it your focus. Because again, my exposure to performance engineering has always been like my service doing something that it shouldn't, and a performance engineer comes by and says like, "Oh, dude, you're leaking file descriptors all over the place. What are you doing?" So that's my exposure, but it's good to sort of like see all of like the activities in one place that performance engineers might have. So that's cool. The discussion topic that I wanted to call out though was this blurb here. I think it's in the second to last paragraph, maybe. Yeah. Brendan writes, performance engineering should ideally begin before any hardware is chosen or software is written. The first step should be to set objectives and create a performance model. The immediate thought that I had was like, you and security teams probably agree very much on that. I'm very well accustomed, and you probably are as well, that security is one of those things that's deferred until later. And I think probably one of the biggest reasons for that is often when you're bootstrapping a new service, you don't even necessarily know what it is. You might have a somewhat rigorous design phase, but like it's at times it can be easier to sort of balance towards the, hey, you're kind of prototyping. We don't even necessarily know if this should be in production yet, as is. That doesn't always happen. I have examples of my own that are literally the opposite of that, where we know exactly what service we need to build, and so there's no chance that it's like experimental or anything. It just fills a role that's very tightly defined, and in that case, I think probably both security and performance can get shifted left quite a bit. If you're not familiar with that term, shift left is sort of like, it could be a little cringy, but it's sort of just the idea of moving something earlier in the software lifecycle. So instead of saying like, okay, I built the service, put it into production. Yeah, let's think about security now. It's more like, let's think about it a lot earlier, and that way you can incorporate it into the design. I think generally it's an unambiguously good default. I guess the discussion topic that I had in mind was sort of the nuance around doing that when the sort of problem domain isn't well constrained. So like if you're working in an environment where maybe you don't even know necessarily how the service should work, and prototyping and rapid iteration is preferred, maybe security can be delayed until later, but it's really a case-by-case basis thing. And then, yeah, maybe performance is the same. Performance, I think, actually probably has more of a it can be a little bit more insidious in the sense that, so I interview a lot of folks for technical interviews, for programming interviews, and one of the common themes is pre-optimization. And maybe this is just the way I do things, but I think a lot of especially engineers that are maybe a little bit earlier in their career, their prep for technical interviews, and I think there's, it's understandable that this happens, and maybe in the age of LLMs this is going to shift, but historically anyway, a lot of the prep involves like leet code, so like go through leet code and just do all these examples and do all the asymptotic analysis, and so you think about time complexity and space complexity and things like that, and finding like the perfect algorithm. And definitely there is a time and a place for that. But often what I find is that candidates tend to try to go straight to that without really even understanding the naive version, and that can result in them having effectively no solution. And I've seen that extrapolate into post interview, sort of, again, if you're trying to sort of design a production system, you sort of think, oh, no, what are all of the ways in which this can go wrong if it expands to this kind of connection count or anything like that. And again, I don't want it's tough to be really absolute about this, because if you say no, don't worry about that, then we will end up in a horrible place from a performance perspective. I know Casey Muratori, who's really famous for his own sort of performance engineering skill set, has spoken in videos at great length about that mindset. And that's definitely not a mindset that I have or advocate for. It's just more, again, everything's about balance. So everything's about balance and nuance. And the question is not should or should you not optimize for performance as early as possible. It's more like do you have a good understanding of the value of that? And even Casey, I think, has actually spoken about this as well, where you get diminishing returns at a certain point. You can optimize the performance of any part of the system kind of ad infinitum. There's really not a floor there, at least conceptually. And so the question becomes, like, at what point are you getting way less value in focusing on performance than you would if just by rapid prototyping and getting something out there? So it's always a balancing act. Anyway, that's sort of like the rabbit hole that I thought of when I got to that part of the book is sort of like the sense that, yes, I think you should at least consider performance very early on, but just, again, be very sensitive to the fact that the trade-off of trying to ensure that every aspect of the system performs like to like the absolute nanosecond scale may or may not be worthwhile. Just something to think about. Okay, so let's move on to page 4. This I thought was really cool too. So on this is one thing that I'm gonna actually start to whiteboard. I don't want to obviously post like the actual diagram, but I do have a little bit of whiteboarding prepared. And forgive me, this is gonna have some rough edges around it, because I don't know if I don't have my OBS set up just yet to like make this not totally suck. So I'll be like switching back and forth manually. So I think, is this ready to go? Maybe not. Oh, no. What zoom level am I at for that? Oh, that should be fine, actually. So, yeah, I'll erase that. So, yeah, the perspectives was really important, I think, too. So there's workload analysis and resource analysis. And maybe actually my scratch pad is better for this. Workload analysis versus resource analysis. And I what I gathered from this is more app centric. So if you're like maintaining a service, and this is definitely my default because I maintain like a specific set of services, and then this would be something like like a dedicated performance team, maybe SRE as well, where they may or may not have inside knowledge on any particular like workload, but they do have broad perspective on like the actual system as a whole, and so all of their methodology sort of starts from that perspective. I thought that was important to call out, because again, like it mirrors my own experience, where I'll have a set of colleagues that don't necessarily know how my system works, but they sure as heck can get up to speed really quickly, and they definitely can articulate, hey, like you're actually causing a lot of problems for other services on this server, and so like don't do that. And so I thought that was really interesting. Yeah, page 5. So this gets into subjectivity and complexity. So subjectivity is a good call out because I mean, even though it's not my explicit focus, I've dealt with all kinds of sort of like, you know, uh, help tickets and things like that, saying things like, yeah, such and such is slow, or something like that. And it's really important to uh, like really work to quantify that for a bunch of reasons. One of which is just that if you can't quantify something, then you can't really reason about like what it should be. And like should be is also a loaded question. Like should be is probably more of a spectrum than like a specific number. It also depends on like what the baseline was, and so if you don't have a baseline of what that number should be, like it's really hard to like make any objective analysis of things. The other thing to keep in mind is that uh, again there is a degree to which you can over optimize something. So like if your service is returning is taking a couple hundred milliseconds to return a response, that's pretty bad. I think more or less objectively, there are some services where that's actually fine, but generally speaking, I think for like typical web services, that's not great. Um, and then getting that down to like 2 milliseconds, pretty great. Um, do you need to then get it into zero point 0.01 milliseconds? No, because nobody would notice, and frankly, that particular example is not really possible. But you get my point. Like, there's definitely a level where you get diminishing returns. I also liked the the complexity portion because it talks effectively about the kind of thing that was discussed earlier on, which is that uh, there's not one aspect to performance engineering. There can be a bottleneck at any part of um, those like 10 components within a single system, and then of course you have the same analysis that needs to be done now across like multiple systems, and so it's really important to consider that the uh, like one of the first steps that you need to do to do performance analysis is understand relationships between these components. And again, this is another thing I want to like park on that I admire about the performance engineering that I've seen is you have a service that has, let's say, 10 components, and they sort of interconnect in this weird way that may not even be obvious, and you may not even have it documented or anything like that. The thing that I really appreciate from the performance engineering that I've seen is that they have really great ways of coming up to speed quickly, and they have these again very generic and portable skills and tools that really don't depend on the inside knowledge, and they can often tell you, and this is true for me, much more about what your system's actually doing than you even thought yourself. And so yeah, that complexity angle is important, and I just mad respect for folks that have that skill set, because it's a lot to deal with at times, sure. Moving on to page 6, I think for this, yeah, we were getting into like, yeah, multiple causes. Again, this is this may be obvious to some, may not be, but yeah, you can't always just say, yeah, there's a performance issue and it's in this one system. It might be uh, the root cause might actually be in the actual way multiple services interact. So the bug, if you will, like if you were to do a write up of like what the actual root cause was, and you're talking about multiple systems, it may not be fair to sort of try to pin the blame to one of those systems because that system actually was doing the right thing. It's in the coordination and how the system as a whole, that service, I should say, that service may not be the one with the problem. It may be the design of the system as a whole, the sort of distributed system, perhaps. So yeah, really, really important to think about that. There's also, this is the thing that really keeps me awake at night, is sort of cascading failures, where like you might have like a latent bug that's almost never triggered, but then a failure that's caused by a latent bug in some other system triggers that, and yeah, that happens, and that can get hairy pretty quickly. So yeah, lot of complexity there, and also teasing out performance issues when you're talking about services that depend on each other. That can get hairy for sure. Okay, page 7. This was great. So this gives and I will draw this, not to try to just like mimic the diagram, but just to sort of just give the general idea of what it's pointing out. So you'll say like in a if you're trying to measure effectively the latency of a given request, how long it takes to pass through a system. You have your start point, and I'm not actually drawing on the screen, am I? No, I'm not. I might invest in a different drawing app for this. This one was just like built into the Apple ecosystem, so it seemed better. I'm gonna draw like little dots here, so that I can like know where the corners are. This is gonna be real interesting, isn't it? Yeah, great. So then I go to, can I zoom that way? Surely I can. Yeah, zoom to selection. Okay, great. So if you have a request that takes, let's say, a total of, I think in the book they show just 100 milliseconds, right? So you have 100 milliseconds. What is occupying that time? I think that's the kind of the point of what this is trying to highlight. There's obviously some kind of computation happening, many computations happening behind the scenes. What is that? And quantifying that, I think, is important. Now, the term that's raised here to describe the different class of tasks that could be happening is on CPU and off CPU. Now, before I get to that, because that actually was a new term for me. I've heard it before, but I don't know that I've heard it as well defined in this way. I probably just didn't think about it at the time. It for me, I've always said effectively like waiting for I/O. That's effectively what it's talking about. So on CPU means literally we're making some kind of calculation, and so a request might come through, and you need to do a database query, and that database query is what's taking the 100 milliseconds. The first part of this, and this is literally from the diagram in the book, the first part of this is some kind of part of the process that might take literally 10 milliseconds, and that might be something to do with whatever computation needs to happen to perhaps serialize a database query, or rather, I guess this is from the perspective of the database, effectively work that needs to be done on the CPU. And then the rest of the oops, I switched to the eraser. The rest of the time is taken up literally by waiting on the disk to fetch some contents. So the CPU is not really doing anything in that case. It's waiting literally for the disk to return information so that it can then move on. And the distinction here is that this is off CPU and this is on CPU. So again, I'd heard this term before, but I think it didn't really like latch with me. I think again, I was just more accustomed to thinking about things of whether or not they are or are not waiting for I/O from like a disk or the network. Typically, the network, that's my background. So typically, I would think, okay, yeah, we've sent the packet out and we are waiting for the response. There's really nothing to do in the meantime, and so we are not, or we are I/O bound at the moment. That's typically how I would say that. But yeah, often on CPU, probably a better way of saying that. Okay. Did I end up showing that pretty well? Okay, yeah, actually, I wasn't even watching my stream preview, so I was worried for a second that I kind of went off the screen a little bit. And what do you know it? We are almost halfway through, and we are an hour into the stream. So, yeah, that first prelude it took up a lot more time than I expected, and probably should have expected it. Okay, quick pause to just make sure everything's good on the stream. Yep, looks okay. Still dropping some frames due to rendering lag, but not that many. The good news is I am recording this, and so hopefully the recording's a little bit higher quality. So if you're getting stuttering on the stream, I apologize. I'm still learning the learning how to stream again. I used to do this a little bit more, but I don't think anything like this. So I'm finding out where all of the wrinkles can be. Okay. So next, page 8. This one's also interesting because if you haven't dealt with production systems and like the observability angle, it may not be obvious. But this is where we get into counter statistics and metrics. And so probably a better thing to do for now is just Scratchpad. So I'm going to say, I'll just say observability for now. Counters. So a good example of a counter that an application might export is requests received. So as your like say you have a web server and that's your service, right? You're running some sort of a web application. As it receives a request, it'll keep some internal counter, and every time it receives a request, it'll increment that counter. So you start with 0, obviously, when you start the application, and then when it receives a request, it increments that counter. Now, what it will probably also do is expose that counter somehow. Now, the example that Greg gives in the book is there are counters being exported by a command vmstat. And you know what? I'm going to cheat a little bit because I actually, like I said, I had the demo prepared. I'm going to cheat a little bit and just show it off, even though I'm not going to be doing anything super meaningful with it until next time. But the example he gives in the book is vmstat, and I have that ready to go. So vmstat, and one, I can't remember what that first param does. Oh, that's just the delay between them. Yeah, that's right. So here, let me shrink this a little bit so that it shows up better. So this is a good example of a tool which monitors effectively CPU utilization on the system, and these are counters of a sort. Like not all of them are incrementing counters, but effectively they're just sort of like, again, they're numbers that represent an aspect of the performance on a system. And so what you might do is you might export the contents of this to some time series database to graph it over time, and that's what gives you a metric. But again, another example might be you literally have an HTTP server, and so you might say, like, here are my metrics, and one of them is requests received, and then the counter will be something like, I don't know, 15. Like, that's how many requests you've received. Now, if you're using a tool like Prometheus, one of the things that you'll probably do is scrape this from something. So like if you're using a built-in Prometheus client, that's actually a web server that's like attached to your application. So you might have like a separate endpoint just for gathering metrics, and of course you'll probably want to protect that so it's not accessible externally, all the things you need to do there. But yeah, you might set up Prometheus to scrape this, and so this is just a point in time. This is how many requests we've received like right now. But then you can use Prometheus or something similar to scrape that at a periodic interval, and then you can plot that over time. So it might go up to 20, and if you're just looking at the counter, you don't know when it went up to 20. You don't know how fast it went up to 20. But if you've scraped it frequently, you are much more likely to be able to see what that rate looks like. And I think that's really important. So Brendan does kind of mention this in the book, where counters kind of go up to... let me see if I can do this a little bit better. And actually, I think the... oh, yeah. That's actually much better. What is this? Oh, yeah. That erases a lot faster. So you have... so counters... Yep. Those feed up into statistics. I understand what he's saying here, but in my experience, the way I should say, not in my experience, his experience is much more in depth than mine. But the way I think about these things is I think of counters as going into metrics, because in my experience, I look at metrics in something like Prometheus, and then I'll apply statistics on top of that. And so it could be that I want to set up an alert for a given metric. And the alert definition might be something as simple as alert if I get over 25 requests. That's a contrived example that doesn't really work, but you can imagine there are some metrics where, let's say errors. A great example is errors. So like errors received 1 or 0, hopefully. So if you have a metric that's exporting that counter, then you might have an alert that says anytime it's over 0, fire an alert. But that might get kind of noisy, because you might actually have a percentage of errors that you can tolerate, and so it might not be a good idea to just have that sort of inflexible of an alert definition. You might want to do something else with it. You might want to apply a percentile to it. You might want to apply a trailing average. So for that reason, I think of this in terms of statistics over that. And then on top of that, I have the alerts. So generally the same. This isn't meant to sort of contradict the example in the book. I do understand what he's talking about here. It's just the way I think about it is this way. Just again, due to my own experience, which is not necessarily the way you should think about it. Okay. Oh, page 10, profiling. Love this section. And the reason for that is I get to talk about flame graphs, which is one of Brendan Gregg's most famous inventions. At least that's what my perspective is. He's done a lot of great things, obviously, but yeah, flame graphs are up there. So flame graphs are awesome, and if you haven't used them, probably the best thing to do is to go over to actually Brendan's GitHub, and I'll bring that up here. And I have it open. There is a GitHub on his profile called Flame Graph. And is this like, yeah, I think, yeah. So he has some examples of where you capture flame graphs. Yeah, and I think some Perl scripts probably for generating these. I don't know if this is like actually how it's. Yeah, I mean, I would assume that I haven't actually looked into whether or not this is a library that can be reused by other tools and like which ones are. But in any case, the the content of this is more important. If you click on the visual here, you can open it here, and I highly recommend that you do because this is actually an interactive SVG. Now, flame graphs are going to have their own section in the book, so I don't want to get too deep into this because what I want to do is create again a demo of a program that's doing something that it shouldn't, and then actually take like a live flame graph of it. But this is, I think, a good teaser. Flame graphs are for profiling like CPU utilization or CPU behavior, I guess is how I would, in my very layperson phrasing, I would say it that way. But the really cool thing that it does is it tells you of the time that your application is spending on CPU, meaning it's literally performing CPU instructions and not waiting for IO. Here's what it's spending its time doing. So it's very much like the percentage of the time that it's taking is being occupied by these operations. And the reason it's called a flame graph is because of the color scheme, but also the stack literally is the call stack. So at the very bottom, you have the sort of the top of the stack, right? So you see this, and then you go up, and then it goes all literally up the call stack. So the higher you go, the higher up the call stack that it goes. And so you can see from a percentage perspective, say like this particular function occupied 18.76% of the samples. Now it is sample based, so it kind of depends on the variables that can be affected by sample based sort of measurements. But I think I have had this used on my services, and I've tried to use it on my services as well, to highlight all kinds of things that that my service was doing and it shouldn't. The anecdote that I'll give to make this a little bit more real, and maybe I'll save this for later, but now I'll give a quick blurb on this. I had a service that had a basically a binary tree implementation. And it was a decent size. I can't remember the exact size, but it was decent size. It occupied a decent size in memory. And there was a bug that was introduced a while ago. I can't remember how even it was introduced, but effectively there was a bug that was introduced where the entire tree, the entire data structure was actually being cloned in memory, a deep clone for every request. And so obviously that slowed the request down, and it also created a lot of CPU utilization because literally half of the time or more, I can't even remember the percentage, but a large amount of the time on CPU was spent literally just copying data. And you could see that very plainly in the flame graph because all of the functionality, I'm not familiar with this particular flame graph, so I don't know if this is true, but the way that it kind of looked was like this, where this biggest portion was literally just clone operations, like memory copy operations, and allocations on the heap. That's what this all was. And then the actual business logic, or the actual logic that my application needed to do like interesting stuff, was all over here. And so it told me like, holy crap, like this is I effectively have mostly a memory copy service, which was not the point, obviously. So yeah, flame graphs are awesome. I can't wait to get into this. I'm hoping that I can build again an example that is compelling, that helps convey its value. because I'm a fan. Moving on to page 11, the tracing. So a little bit there. I've, honestly, the first time I ever really used tracing, other than like traceroute, again, network engineering background a little bit. So traceroute, that's kind of like when I first hear the word trace, like it took a while to break that. Then I did a lot more with like distributed tracing. So like in Jaeger, that was sort of my foray into what I think part of what will be discussed in this book. But in this context, tracing, you can think of it as like event-based logic. And I did a little bit of this, and so again, I might do a book club on this book in particular, maybe even after this one. But it's another Brendan Gregg book. It's called, sorry, the glare is horrible. BPF Performance Tools. There we go. Sorry, my lighting is really good, but not for showing books live on stream. Yeah, BPF Performance Tools, Linux System and Application Observability. I have not read through this fully, but I have used it as like a reference. So there's tools in there that I think we're going to get into at least briefly in this book, that use things like eBPF. There's tools that actually use eBPF behind the scenes, but also make it a lot easier to consume, like BPF Trace, which allows you to inject trace points in either kernel function calls or user space, like application function calls. And this idea of just sort of like not manually, that's not the right way, but sort of dynamically injecting trace points to do inspection and like print things and run little bits of logic to help illuminate what the issues are. I've always admired when folks employ that. I've done a little bit of it myself. I need to do more of it, but it's very useful. The call out that made a lot of sense to me in the book was you use tools like top to sort of say, okay, what's my memory utilization on this system, or CPU utilization, and sort of again it runs similar to VMstat, where it sort of updates at a certain interval, but not every issue can be captured well that way. Like it could be that there's huge variations in what a given system is doing, and top may or may not convey that very well. And so adding the ability to have tracing in your toolbox, I think is really, it's good, because then you can say, well, actually, I want to run a bit of logic on every single time this happens, regardless of some capture interval. And so it's a good thing to have in your toolbox. Real quick, I'm going to do another hydration break. And actually, I'm going to be right back, literally 20 seconds. I'd like to turn a fan on in here because I closed the doors and I forgot how hot it gets in this room. So I'll be right back, literally 20 seconds. Okay, back. Thank you for bearing with me there. Hopefully this isn't too, I have a fan running it. Hopefully this isn't too hair messing upping, whatever. Where was I? Page, I think 11? No, we went a little further than that. 12? Yes, so 12, and now I think we're on to 13. So page 13. Great. Yeah. Page 13, experimentation. I struggled with the distinction that Brendan was trying to make here. I think, well, the mention that like observability is sort of like the go-to for a production system, because it's generally read-only. Like you're not actually like actively doing anything on the system to figure something out. You're sort of, again, exporting counters and metrics and things like that. That stuff you sort of set up in advance, and it kind of just runs alongside your app. And so using the data that comes out of that obviously should be your first go-to, but sometimes it's not enough. And I think that's the point he's making, is that experimentation is sort of like the ability to try to, like, what I gathered from it is that it's about reproducibility. So trying to reproduce the problem maybe in a different way, or at least the same way but with a different tool perhaps. So like generating synthetic traffic, I think, is a general way of saying that. He kind of does that in the book, where he uses iPerf to generate a TCP network he called but micro benchmark. Um, I think that's what he's talking about there. It's just I think what threw me is just the experiment, the term experimentation. I don't know. I no, no. I don't have a problem with him using that. I'm sure there's a reason he used it that way. But it's just I would just call it sort of reproducibility or something like that. But I don't have a problem with it. The name. The point is extremely valid though. Is again, it's like there's only so much that observability can get you. And in my experience, observability is often it's actually quite rare for metrics and things like that to be a diagnostic tool. It's more often than not simply an indication of a problem. It doesn't necessarily tell you. It doesn't even give you necessarily. Sometimes this is not true, but most of the time, it doesn't give me enough to know with certainty that I know where to look for a problem. So the point I think he's making is that having this other aspect to this where you marry the signal that you get from observability with the ability to try to reproduce it using some of these other tools, totally agree with that, 100%. The anecdote I'll give here is we have I have a service that I operate at work, where we sort of we're systems engineers, and so we build the software and then we operate it to the extent that we're able to, and part of that is tooling for actually sending synthetic traffic through our service so that we can inspect it a little bit, making sure that it's working the way that it should, and so like if we get a customer complaint like, hey, your service is slow, we can create a reproducible example, maybe on a non-production system, for example. So yeah, definitely want to have that kind of thing in your tool chest. And then page 14, I don't really have a lot here. I think I mentioned this at the very top, just because of the Terraform content in the GitHub repository. But I don't actually have a lot to add here in terms of cloud computing. I've used cloud services, and when I say cloud services, I'm sort of trusting that if you're watching this, you're fairly technical, and so you're not imagining that I'm talking about like some SaaS app. Obviously, we all use like SaaS apps. That's like 2026. That ship has sailed. I'm talking specifically about like infrastructure as code or higher, right? Where you're talking maybe platform as a service. Infrastructure as code is not what I meant to say there. Infrastructure as a service, platform as a service, things like that. Now that's totally not true. I'm saying other than my employer, which you could argue is one of those, but I'm going to leave that out because I'm not. Yeah, that's not what I'm talking about in this context. I think the context of this particular section is, again, like you might have a virtual machine running in, say, Google Cloud, which is what I spun up for the examples here. There is difficulty that can be introduced here, where if you're in a multi-tenant environment and the boundary between tenants is like extremely opaque, which is often the case in these systems, and that's for good reason, for security purposes, right? You're running, you're putting different tenants literally with hypervisor isolation. It's impossible really to do full systems performance analysis. And so I think just the call out here is like, hey, guess what? This is going to be kind of a difficult, or this might require some nuance that might not be obvious to you if like me, you haven't spent years and years and years operating services in cloud infrastructure. Again, my experience is all effectively bare metal. Like I just have direct access to stuff. So yeah, really looking forward to it. It says chapter 11 is when he covers that in a lot more detail. So looking forward to that. I think it's fairly obvious that he has a lot to share there, because if you don't know Brendan Gregg, he used to work for Netflix, and Netflix is famous for running all their stuff on AWS. So yeah, lots of great knowledge to share there. So not chapter, page 15. This gets into methodologies, which is a little bit of a tease because chapter 2 is literally about methodologies. But the thing I appreciated about this is, again, having all of the checklist all in one place. I think having an SOP for, like, one of the things that I've learned over the last couple of years is anytime you have some sort of a production issue, it's great to try to capture that, like the steps to figuring that kind of thing out in an SOP, so you have to do less sort of it reduces your cognitive load over time. And the checklist here, I think, is a set of commands that you can run. But I mean, to be honest, what I've really liked to do is just a markdown file for really specific issues. So if you're looking at like file descriptor leaks, here's the first thing to look at. So yeah, having that captured I think is a really good idea. Oh hey, JD Silva BE. Sorry, the light's kind of in my eyes, so I think I'm reading that correctly. Hey dude, hope you're doing well. Just pop by to listen in and see what you're up to. I am glad to hear from you. Yeah, thanks for joining. And yeah, right now just going through systems performance. And I would love if you have any insight into the topic. Anything interesting to you? Like I said, I I I. I'm not one of those people that loves hearing their own voice. So this is actually really unnatural for me. So literally, you would be doing me a favor and this is a message to everybody. Like you'd be doing me a favor by just sort of saying like, "Hey, that's interesting," or like, "When could that be useful?" Maybe give another anecdote. Literally anything like that would be really useful, and that way I have some sense that what I'm saying is useful to somebody other than myself. So yeah, good to hear from you. Um, where did I leave off with that? Oh, the one point I wanted to call out here is in methodology. So I have just again as an anecdote, I've tried over the last couple of years to capture. So I use Obsidian markdown files in an Obsidian vault where I try to capture a lot of things, but one of the things that I have in there is just SOPs for any issue that I might need to look into. One of the really encouraging things about lately, and I have a lot of thoughts, not all of which are going to be as positive as what I'm about to say, on like LLM usage in programming, but also just in systems in general. One of the absolute best things that I have done in this regard is actually capture a lot of those SOPs. They're already in Markdown form, but restructuring them to like agents and tasks or and skills. So I use OpenCode and a few other tools like that, and actually putting the SOP in that format is really cool way to sort of shrink the time it takes to do initial triage. So if you get paged for a particular issue, you might say, okay, this table in the chapter in page 15, you might capture all of those commands in a markdown file that says run these commands, give the output, and provide maybe like some basic analysis. So then instead of having to run these commands yourself, you can literally type into your little agent in OpenCode, say like, hey, I'm looking into this issue. Please run the initial triage and say anything, point out anything that might be interesting. That is like an unambiguous win in my book, because there's just no value in being forced to run all these things manually. Now, of course, if I want to drill into something in particular, then I can pick up where maybe that left off. But man, I am such a fan of using these tools for like read-only analysis, even if it doesn't give you the answer, and it almost never does. But it is really great for doing like initial triage tasks and getting you to like the actual valuable debugging much more quickly. My God, it's been great. I again, this is sort of, it feels weird for me to sound so positive when talking about LLMs, because I have a lot of negative thoughts too, but it's a nuanced topic with me. This just happens to be one of the areas where I've had a lot of great success in using those tools. So I just wanted to call that out. Okay, so we're actually getting to the end. I don't know if I really want to go through like there. So the end of the chapter is the two case studies. I don't have a lot to share there. There's two. There's one that talks about slow disks, where an engineer was sort of troubleshooting, database performance. Definitely read through that. I think I would probably not do it justice by trying to like summarize it or anything weird. The thing I'd point out is, I think I mentioned this before, but I think it's a good example of like a multi-team investigation. So that's like always what I see. I very rarely see, if we're investigating a production issue, it typically touches more than one system. And so getting multiple teams involved is extremely common. And so this is a good example of that. It also is a good example of what happens if you like sort of a canonical noisy neighbor problem that doesn't have any sort of like multi-tenant kind of. Multi-tenant's not the right way of saying it, but just like things like C groups, just kind of it's sensible stuff that can help protect against things like that. But none of that stuff's a panacea, so it's just tools in the toolbox. And then case study 2 was, I think, more of like a software regression, if I recall. Definitely loved the usage of flame graphs. I'm fawning over over flame graphs a little bit, but they really are cool. I'm actually super excited to get into them because I really want to build like a real example that makes it obvious, and not so contrived. But yeah, I just left the flame graph on the screen just for decoration because I love them so much. Okay, so that is the end of the chapter. I am going to real quick just do a little bit of a stream health check one more time before I get into the wrap up section, because there's a few things I want to cover before I actually disconnect here. Yeah, wow. Decent number of dropped frames. I wonder if there's my upload speed is not great at my house, so I knew that. But I thought I enabled like dynamic bitrate in OBS. I've also seen OBS like literally forgot some of my settings, or forget some of my settings. So it could be literally that it just forgot one of my settings there. Again, I'm still getting used to this and having like, again, speaking of SOPs, having like an SOP for going through this stuff. But yeah, going through all my OBS settings is something I'm still getting used to doing. This is the question on chat. This is Systems Performance 2nd Edition. What chapter were you just looking at? Yes. So this is Systems Performance 2nd Edition, right? Yes, Systems Performance 2nd Edition. So I'll show it here on the camera. Sorry, yeah, again, my lighting's great, but just like it's not great for showing glossy paper. There we go, that's a little bit better. So yeah, Systems Performance Chapter 2, 2nd Edition, and we just did Chapter 1 today. So only, even with like the big prelude that I had at the beginning, where I was sort of kicking off this stream series, it still only used an hour and 24 minutes at my estimation right now. So the other streams will probably run about as long, maybe a little longer, but we'll definitely have more actual like content in them. And yeah, if you have any feedback for like what kind of things are useful to show, I'm expecting to make improvements to like the way I do this series like over time. OBS is a beast. It is its own specialty. Yes. So I just for context there, I used to stream like mostly gaming, so I'm not unfamiliar with it. But this is definitely the first time where I've had to like really like look through all of the settings. I'm also like recording to disk while streaming, so that I can make sure that I have like a much more high quality thing that I can post to YouTube, but that isn't like different from Twitch. And if you do export to Twitch, it's not nearly as good quality. So I want that as an option. So yeah, getting into all that depth has definitely been a learning experience. I have no arguments against that statement that it's its own specialty. I'm sure it is. Oh, that's right. I had a few things I wanted to talk about here at the end. Yes. Okay. Yes, great. Sorry, organizing my thoughts here. So yeah, the few things that I'll leave you with are definitely check out the GitHub. That is going to be where a lot of the materials that I'll be posting will be located. The one that's top of mind right now is that I'll have a live demo that I'll be walking through, and the code for that will be in the repo. It's actually already written, but I just haven't posted it yet because I moved that to week 2. So yeah, definitely check that out. For updates, my socials are available here, ozwalt.dev/links. Again, subscribing to YouTube and Twitch, obviously best way to get up to date on like video activity, but the other socials probably better for any sort of like last minute changes to the schedule or anything like that. And just to reinforce that, the next stream I'm aiming to cover all of Chapter 2. That's going to be obviously much more substantial than Chapter 1. But again, since I won't need to do so much housekeeping up front for that stream, I'm hoping that won't be a problem. The pacing that I mentioned here at the beginning is, again, I'm going to do every 1 to 2 weeks. I think right now I can do that next week. But again, stay tuned to socials for news. if I need to delay by 1 week, and hopefully it'll never be more than 1 week delay, because I don't want to go too long in between chapters. Otherwise, this book will take forever. But yeah, my current goal is to cover all of chapter 2 on the next stream, and that might require me to go one more week. But my current estimation is I can do this next Saturday. So we'll just have to see. But yeah, staying tuned to socials is the best way to do that. I'm gonna just type out conclusion, GitHub, paste these in, just so it's not coming out of only my mouth. You can actually see the links. And again, I'll be posting these in the actual YouTube video description. So if you're watching the recording of this, just look in the description. I'm going to put all this stuff there. Next stream, probably 1 week from today, same time. That I can be very consistent on, unless, again, I have to change for some reason. But I of all the things that I might need some flexibility on, I think that's the least likely. So, yeah, probably, again, 1 p.m. U.S. Eastern time. I can't imagine that I would need to do something different. I originally was going to try to do really early morning, and that just didn't work out. I actually have been recently getting up a lot earlier in the morning, but there's a big difference between getting up early and then being, like, ready to live stream something that early. It's very, very different. So, yeah, 1 p.m. is a lot better. 1 week from today, covering all of Chapter 2. Stay tuned. Socials for news changes. Okay. Unless there are any lingering questions, I think I'm ready to call this one. Thank you for watching. Thank you for engaging in chat. Really appreciate that. Honestly, I wasn't expecting that on the first stream because it's actually a new stream channel. I'm not even using my old channel because it's a new sort of like quote brand, if you will. Like it's a new concept. It's not just gaming. I might game on this channel. Who knows? But yeah, for this, I'm trying to keep it sort of restricted. So I wasn't expecting anybody to pop into chat for this one. I do appreciate you doing that, though. It encourages me to continue. I hope that continues because again, this is like a new thing for me where I'm learning too, and I love the external perspectives. I originally got into like blogging for that reason, where I got external perspectives from people who knew more about a specific topic. So this is very much in that same theme. But yeah, thank you for watching. If you watch the recording, again, watching live is something I'd encourage you to do so you can participate in chat. But yeah, next stream, let's currently plan on next Saturday, 1 p.m. Stay tuned to socials for news, and we'll be covering, hopefully, all of Chapter 2. Looking forward to it. And thank you.